All right. All right. So, okay, great, great. Good morning, Mehndi. And all right, so we can start now. Okay, so before we start today's session, do you have any questions for me? No questions? All right, all right. So, so far we have covered few things. We started with the general big data. Okay, all right. So again, a recap as a quick motivation, as in what is it that we are going to do, and are we on the right track? Okay. So when we say analytics, okay, since the analytics is still the real game is yet to started, I'm going with the foundation parts still. Thereby, I want to do a bit of a recap. So, not recap as in give you a little bit motivation why we are doing what we are doing right now. Okay, so analytics is something like find the find the average age of people in various cities. Okay, so the questions that you might have to answer as part of analytics is this. Okay, and present it present it on graph and on maybe a map, maybe a world map, and on bar chart. Okay, this is like very simplistic way of looking at analytics. Then analytics could be this is like very simple one. So the analytics could be various cities of a country of a state. Okay, so in a state there could be maybe a million people. So out of that million people, you have to prepare, okay, this kind of thing. So that's like very simple, can be done easily with SQL and usual BI tools. Okay. Now the second objectives. So analytics objectives examples. Okay, the examples could be like this, or it could be a little more complex. Okay, the moment you have to do the same exercise on average age of people in country and do it every day, or not every day, yeah. So if you have to do this, so every average age of people in the country, or uh, in various cities of world. Okay, so when you do this kind of problem, even though data looks small, but usual systems would find it really difficult to get it done. All right, so then the situation could, as our data is growing, the situation could change. Similarly, if you have to do certain So again, your analytics may become more challenging. Either your problem statement is complex, or your data is too huge, or you have to do the computation very, very quickly, maybe in the real time. Okay, so other examples of analytics would be, show us the sentiment analysis of the sentiment analysis of our brand. Okay, the other objectives of analytics would be that, given a hypothesis such as the interview process is biased against women. So let's say, given this kind of a hypothesis, the interview process is biased against women. So given such kind of hypothesis, uh, okay, or let's say validate a hypothesis such as the interview process is biased against women. All right. Now there could be a bigger challenges such as, given a list, given the details of all of our products, okay, given details of all of our products, prepare hierarchy. Okay, so you are given the all the parameters of all the products being sold. Okay, or let me make it a little more sensible. Given the details of all of the cars, prepare a beautiful hierarchy, as in hierarchy or tree, depicting which cars are closer to each other. 6. Given given uh, say 100,000 emails, given 100,000 email, create 5 groups of email based on their words frequencies. Okay, so uh, basically the way it happens is, you're given a huge huge corpus of data, huge data, and you have to find out the you have to create 5 groups of email based on the words, right? So these are the kind of challenges that you start with. Okay, so as you can see that, sorry, so these are the challenges you might have been would be asked when you work as a data analyst or big data analyst. And as part of your job, you have to understand most of the tools on the surface, as well as some tools you have to go into detail. That's why generally you starts with basic mathematics, then you go to statistics, and then you go into a bit of detail about the other tools such as maybe R. And then when the data grows big, you have to understand big data and ecosystem, big data and ecosystem. Okay, for both. Or I forgot to mention, in the real time, a real time trend could be present the orders being processed every second. Okay, and also display, if I had a diagram I could have shown you this. Present the orders being processed every second in various statuses. See that? All right. Okay, so these are the questions that need to be asked, that would be asked. So you start with mathematics, you start then statistics, and then R, then big data and ecosystem, and then you go into more and more details. Okay, so also we will talk about this as part of the stream processing. We'll talk about those components as well. Okay, and stream processing. Good. So I hope the objectives are very clear to you. All right. All right. So yesterday we talked about a new database called MongoDB. And why are we talking about MongoDB? Because our data could be stored in MongoDB. We might have to use MongoDB to store some kind of data in order to do various kinds of operations. So So generally, the data analytics work sounds like a very read-only kind of data work, whereby you don't have to make changes to the data. But that's not entirely true. That's not entirely true. Sometimes a data analyst has to understand how well, what all architectures he might have to use in order to give analytics, and for that he might have to store the data somewhere, or change the structure of the data in order to give the good analytics. Because if your algorithm is uh, even so sorry, if your data is well structured, your analytics, your way of doing computation is going to be very simplified. Therefore, analyst cannot say that I don't care about I don't care about the systems underlying. All right. So yesterday we talked about some database called MongoDB. MongoDB is basically a collection, basically a document-oriented database which provides you collections, and inside collections you can store inside each collection you can store a document. A document in case of MongoDB is a big JSON object. What is JSON object? JSON is kind of a representation, or a format, so that you can present a complex object in text. Okay, so JSON is basically a plain text kind of a model. Although there is another thing called BSON, which is binary JSON. Okay, but JSON is like plain text way of presenting data. All right, and you can present very complex data. So MongoDB provide you a concept called collection. Collection is similar to your database table. In database tables, colle- uh, uh, database tables are basically set of the unordered set of the rows. Here, a collection basically is a collection of many documents, meaning JSON objects. All right. Good. All right. Now there is something interesting uh, which we had planned last time, but we were about to start that. Okay. So the most important part about MongoDB is its architecture. MongoDB is not a single machine. MongoDB is not a single computer. MongoDB runs on many machines parallelly. MongoDB runs on many machines parallelly. Okay, so how does it work then? If there are too many machines, which one will you talk to? How does it keep backup? And who takes the write? Should if you push some data, will we be able to write on all the nodes? So how does it work? All right. So first of all, let's understand a concept called replica set. Okay, a replica set is a collection of nodes. Okay, collection of node as in, let's say you have three computers. Okay, and on these three computers you have marked in the configuration that the MongoDB on these three computers is part of a replica set. Okay, all right. So a replica set is nothing but a group of computers. It's a group of computers which is which may be made of one, two, three, four, five, any number of computers. Okay, and all of these computers have the same data set copied all over. Okay, so which means that if you have 1 GB data and your replica set has three computers, this 1 GB data will become 3 GB data, right? So that's what is a replica set. The objective of the replica set is the high availability. Meaning if one of these nodes go down, somebody else will take care. Okay. So let me try to explain it again. So a replica set is a collection of computers which you configure that okay, these three computers are part of my replica set 1, and these three computers IP address is this. So now there are these three computers which are part of one replica set. Any data you write to one of them, okay, before we come to the writing part, let's understand. So out of these three computers, which one will accept write and which one will accept read? So unlike our name node where we had handpicked one of the nodes as name node and rest were marked as earmarked as data nodes. Here all three computers which are part of the replica set, there could be more computers, I'm just taking three as an example. So all the computers in a single replica set, okay, are identical. You do not mark that this is my name node and this is my, no, you don't do that. But replica set has one node called primary. Then how does somebody becomes primary? This interesting part. So these three nodes which are running MongoDB, when they discover that these three nodes are in the same replica set, they start voting for each other. They start voting like a real voting, so that they can select somebody called primary. All right, so replica set contains one primary, rest are secondary. So the role of a primary node is to provide the operations which can change data, so that if you have to write, if you have to create a collection, update a collection, delete some documents. Okay, so all those operations which modify data go through primary node. Okay, they go through primary node. So all the members of the replica set vote for each other. Whosoever gets the highest vote becomes the primary, and the voting is based on two aspects. One one how fast is it replying to the pings? How many of the ping packets are coming back? Ping as in there is a network of ping. There is a process called ping where one computer tries to just send a minimal amount of data like hello, and then the other computer responds to that particular data. So it's the ping is basically to know how is another computer responding. So so based on that, one of the primary nodes is selected, while secondary nodes are only for reading data. When the users, you can see that. Okay, so when the users, there is a client driver. Client driver is just like your JDBC driver. The client driver is something which you will be talking to, or your application will be talking to client application driver. So this driver, when we ask driver that, hey, can we create this document, it will go to the primary. But if we say that, hey, we want to write some data, we read some data, in that case this driver will directly go to the secondary node. Okay, now sometimes what happens is some of the nodes in this. Okay, so let's say there are primary and secondaries. In case primary fails, then somebody else will become the primary. Somebody else will be voted as primary. Sounds good to you? Hi Anusha, welcome to the session. And all right, good. So I wanted to show you some very important aspects of voting. All right, so and also in a replica set, all the nodes contain exactly same data. All the nodes contain exactly same data. If you have 10 nodes in a replica set, then for storing 1 GB, the total amount of data that will be the total amount of disk that will be consumed will be 10 into 1 GB, because 1 GB is going to be copied to all the members in the replica set, and therefore it will be 10 GB. Okay, so we have primary and secondaries in case of MongoDB, and that's one important aspect. Okay. Next is that MongoDB provides something called sharding. Okay. So what does it mean by sharding? Sharding means that the driver will talk to the Mongo S, which is another daemon, and then that Mongo S will redirect it to various shard. Okay, let me take a step back. So if there is if so okay, let me try to explain what does it mean by a shard. A shard is the section of data. Okay, if your collection is big, some of the some of the data of a collection will go to one node. Some of the data of the collection will go to another node, and we call it sharding. Sharding means slicing the data into sections, slicing the data into parts, and dedicating different nodes or shards to this data. Okay? And this shard, when we talk about this shard, it could be a single node or it could be a replica set. It could be a single node or it could be a single node or it could be a replica set. Okay, so the driver will so if your system has been configured to have shard, which means that you are slicing the data onto multiple computers. Okay, while replica set helps us in availability and keeping the data backup, right? Sharding helps us in providing the overall throughput. Okay. And also sharding makes it possible to store humongous data in MongoDB. Okay, so a collection is like a table. Collection is sliced into parts. Some part goes to shard A, some part goes to shard B, and some part might go to shard C. Now these sections are the no, the information that which part of the collection is where is stored in MongoS. MongoS keeps a note of which key ranges are in which shard, and thereby whenever a request from driver comes up for a key, it basically asks the corresponding shard. All right. So MongoS stores metadata in config.db. So MongoS maintains one more instance of MongoDB called config. It's a stateless. It tries to identify the shard for the query. So whenever user is asking for some data, it will figure out where that data would be and then ask only those computers. So you as a user of MongoDB will not be talking to Shard directly. Instead, you will be asking Mongo as Mongo Shard server, and then that server will be redirecting you to various shards. Okay, does it make sense to you? Great, great. All right. Now you can see that we first started with an individual shard. This is actually a shard, single shard, or also a replica shard. So one can I show you with some other diagram? Let's say there is this big data set you have. It has got much of data. Okay, it has got much of data in it, and then when we send it to a shard, this is our say Mongo S. Okay, it will send it. It will consult somebody called a configuration server. Okay, it will consult config server where to send this shard. Okay, this particular collection, not shard, this particular collection where to send it, and then config will say okay, send it to let's try to make a big box make a big box. There are, let's say, two boxes for now. Okay, so then it will give some of the data some of this data to here. All right, and some of it would go here. I'm not able to divide, let's say. Okay, one part went here, other part went here. You can see that. All right, so this is shard 1, this is shard 1, and this is shard 2. Okay, and this shard 2 will contain the replica set. Okay, there'll be somebody primary, and then there will be somebody secondary, another secondary, and another secondary. Okay, so let me try to I think a better way would be, let's say this is 2 GB data and 1 GB went here, 1 GB went here. Okay, now here 1 GB, okay, on primary, secondary, secondary, secondary. And see that? Now maybe here, so what we are trying to do here is this is election, based on election. They have selected this guy as primary, this particular node as primary. All right. Similarly, there could be maybe two nodes, only two nodes. One is primary, other is secondary. Generally, it wants at least three nodes, so we'll not go with that. So we'll have at least three nodes. So here there'll be, you can see that 1 GB, 1 GB. Now, how much is the actual storage for 2 GB data? Anyone? So we had 2 GB data was sent by the driver to MongoS. MongoS talked to two shards. So this is shard 1, or you can say replica set 1, and this is shard 2, or you can say replica set 2. Does it make sense? So if we have 2 GB of input data, how much of total storage was actually consumed? Mehndi and Anusha? I know I'm pretty bad at drawings. Yes. All right. Let me try to spread a bit. If we have 2 GB data, how much of total actual storage it consumed? So 2 GB, 1 GB went to one shard, 1 GB went to another shard. Now this 1 GB got replicated thrice. This 1 GB got replicated four times. Now, Mehndi, Anusha. So we had 2 GB data in a big document. You're trying to store a document. This MongoDB will divide it into two parts. Let's say in 1 GB plus 1 GB. This 1 GB got replicated thrice, and this 1 GB got replicated four times. Now, did I confuse anybody? Yes, that's right. It will be 7 GB, correct? It will be 7 GB. 1, 2, 3, 4, 5, 6, 7. Right? So whenever you are doing the capacity planning, you generally take care of these things. Okay? So generally, the decision of replica set is based on how many members are going to be in replica set is based on how reliable is data center. If your data center is having old computers, or those computers or the network is not very reliable, then you generally go with more number of replicas. If your network is fairly reliable, then you go ahead with less number in a replica. Okay. Any questions, Anusha, at this point? Yes. So replica set. So Anusha's question is. Anusha's question is. So replica set is a part of shard. Yes. So from the point of view of sharding, there are shard 1, shard 2, shard 3. There could be multiple shards in which sections of data will be stored. Now this shard, okay, shard could be a single computer, or bunch of computers. If you have a bunch of computers, then you call it a replica set. You'll define it like a replica set. Make sense now? So shard could be a single computer, or it could be a bunch of computer, or a replica set. Any questions at this point? All right. So did I make sense, Anusha? All right. So here a collection or a table is being sliced into parts and being stored on multiple computers. An individual node thinks that that's a complete collection and it stores it. Okay. So MongoDB or MongoS stores metadata in config databases and is stateless because it stores the data in config, so it doesn't keep anything with it. Tries to identify the shard for a query. So the apps talk to the MongoS, not to the individual node. Okay. All right. Now, in case of auto sharding, because MongoDB has auto sharding, nobody divides the data manually. Auto sharding is automatically there as part of MongoDB. Sometimes you may not like the default strategy on what basis it is slicing or distributing our data. Okay, so you may not like it all the, and therefore you might customize it, but by default it provides you that. Okay, so here you can see that there is an application server, one application server, other application server, or more of the nodes. Okay, and these nodes, these routers or MongoS talk to the configuration server. These they talk to the configuration server, and then they talk to the replica set or a replica shard, whatever you want to call it. Okay, so all right. So application server talks to MongoS talks to the shard, all the shards, and then responds to the application server. And that's what is happening everywhere. Okay. So if you, all right. So a question from Mehdi. By default, how many replica will it create? Depends on how many node you define as part of a replica set. So if you have created a replica set with 10 node, then it will create 10. If you don't, if you have just have one single node installation, you just downloaded MongoDB and started using it, in that case it will be single copy. All right. Good, good. And any questions, Anusha, at this point? All right. So MongoDB is first used for storing huge data, and I'll try to show you. I'll try to show you a little bit hands-on. I think before we get into more details, we should do some kind of a hands-on. Okay. So let's just log in first. Let's just log in first. All right. So if you say Mongo here, you see the command console, and over here you could basically start reading the data. Okay. Show collections. Does it show collections? No, it doesn't have any collection. Okay. Or we say show DBs. Okay, nice. We have DB here. Say we have session 2. Okay, we can say show collections. It shows the collection called class collections. So we can say db session 2 dot collection dot what was that, find. Okay, so this is how individual object looks like. Do you see that? It says that there is an ID which is a unique number defining this particular object, and there is a name, there is a value, there is a name, there is a value, and so on. Okay, so if you have to format this nicely, there are many JSON formatters. Okay, let's just try to make it look like an array. You can see that it is well formatted now. Yeah, you can see this is a collection. It has got 3 documents, 1, 2, and 3. It's a collection where every document is identified by an ID. It has got, every object has got some values. Okay, so it's a collection of such kind of objects, right? So we said, okay, in case you are wondering what did we do, so first of all here, to understand what a database is, because the data inside collections are organized based on the DBs. You can think of DBs like folders in which the collections are kept. So you can use various kinds of DBs. Right now there are session 2 and this. To use a particular DB, you can say session 2, use that particular DB name, and then to find out how many collections are there, collections as in tables. Okay, so these many collections are there. So this is a test collection somebody has created. I think some student only created. Okay, and I'll have to say db dot session 2 and then. So there is no data in this, but in this particular collection there is some data. All right. Let's say we want to create our own data set. So we can create our own data set. All right. So we have created an empty collection, okay, called X. We have created an empty collection by saying db.x insert empty. So it has got only one object which is totally empty. Okay. I think there was a function called drop or something. Yeah. So show collections. It is deleted now. Right. So we can say db.x.insert, and let's say I'm saying name colon Sandeep. So I'm trying to create a collection with these properties. Age is 20, and nose colon, let's say MongoDB and R and header. Okay, so this is an array we are trying to define. All right, did we make a mistake? Yeah. All right, so we can say db.x.find. Okay, you can see that. You can see that it has created an identifier automatically, just like auto generate ID. If you want, while inserting the data, you could also say things like this. You could say ID is 1. Okay, so you can say db.x.find. Here the ID will be 1 instead of auto generate. So you can either define your ID or you can use the ID generated by MongoDB. Okay, did it make sense to you? Was I able to explain? So the syntax is, first you to see the databases you can use show DB. To use a particular DB you can use DB, and then you can say show collection and it will show you all the collection under a particular DB. Then to insert data into a particular collection you can say db.myCollection insert particular this. Okay, and afterwards you can use db.find. Now db.find is quite helpful. Okay, so you can say db.help, and then, or you can simply say help and say db.find. Okay, so help, there was a way to say db.x.find. db.x. All right, so yeah. All right, so there is a way to find out about every function. Right, so this was a quick hands-on with MongoDB. You guys should give it a try. All right, there are a few more very interesting questions from Anusha. Question is, what is the use of creating more replica set? Yes, anyone? All right, let me go back to the diagram. If you had 4 replica set like this, let's say we had one more replica set here and one more replica set there. Okay, Okay, let's say we had this kind of situation. We had these are two more replica sets. Yes. So good, good. Thank you, Mandy. One is that you have high availability. Okay. Second, the failure chances decrease. Since you have many copies of the data and many machines containing same data, therefore both, as in you got more computing power to compute on the same data, as well as you got more nodes, you got more backup copies. Okay, so more backup and more availability. Yes, fast computation. Okay, since you have more replica set members, so what will happen is, hey, I'm sorry, I thought I read the question wrong. I read the question wrong, extremely sorry. So yeah, yeah, I think I need to pay more attention to my words. Okay, so yes, no, so it's not high availability, or no, not more backup. So when you have more replica set, so instead of this data getting divided into 1 GB, okay, okay, or you can say this data will get divided into zero point 0.5 GB and zero point 0.5 GB. Okay, so the data will get divided into multiple computers. So yes, we will have fast computation, good, and also in the sense of basically we were able to divide the data. Therefore, availability will be same because data copies are going to be same as previously. Okay, computation and lesser load. Okay, high throughput. Let me put it this way. Okay, because now earlier there were two nodes who were catering to sections of data, but now there are more nodes. Okay, now why would it not increase the backup or the or the or the chances of failure? Because this zero point 0.5 gigabyte will be copied again only thrice, the way we had here thrice, four times thrice. Similarly, it will depend on this particular section of data will have those many copies here. All right, Mehdi, was I able to clarify, make it clear? Great, great. All right, thank you. Very good set of questions. Keep those questions coming. All right. Now, that was about the very simple way of storing data, churning data. But sometimes you have to churn a lot of data. Okay, and you might have to do a lot of complex computation. So MongoDB provides a great index on the field. Even though, even though my data is structured like this, let's say my name is Sandeep, okay, and my education is, again, look, so let's think about education here. All right, So inside education, education could be a complex object. It could be another this. My BTech is from some college. My 10th is from some school. Okay. And my 12th is from some school. So that's my education. Okay. All right. So let's say there is another subtitle called project, or let's say jobs. Okay, jobs. And I say here the key is Amazon, and under the Amazon key we could have more details, as in we could have things like project, designation, and and duration. There could be this kind of a structure. So you're and let's say you want to query on where you want to find out all those objects for which education is who have done education in IITR. Let's say you are trying to look up all those people. So it'll be easy if you could index things on this. And beauty of MongoDB is it provides you that deep indexing. Okay. So it understands the JSON format when you put it, and then it indexes the data based on the key values. You can define that index. All right. So let's, what was that? Okay, db dot or class collection dot find. If I want to find out, if I want to find out all the people is Zoe, whose name is Joe, we can quickly do this. You can see that we were able to quickly filter those records whose name is Joe. Okay. And we can basically form similar kind of complex queries over a collection. Okay. All right. Now, so we can create the complex queries like if I insert this, let me try to put this into my db.x.insert, and here I'm trying to put this object into a collection called x. Did I make a mistake? Is this a mistake? It says unexpected identifier. Alright, so I think the mistake was in that. So you can see that when I say df.x and find, it basically lists all the object. Now let's say I'm looking for people whose education.btech is IITR. Okay, so what will I do? I'll say db.x.find and I can say things like education dot btech equals to idea. You can see that we were able to search on that particular field. Good. Let's just test it, and let's say Anusha, and I'm just putting some data. You can see that it's actually working fine. So we are looking even inside, we are trying to search based on the parameters of this object which we are inserting into database. Therefore, even if we have really complex object, we can search on various attributes of this object. Alright? So that's how generally the find works. Alright? So let's take a break for 5 minutes. Back by 9:10 p.m. IST. All right, so I'm back. Should we start now? Great, great. So as I demonstrated to you earlier, that we will be able to search based on internal fields. So if you have a complex object, you can search based on attributes of the object. You don't have to try to force it into becoming a database table. This is a very, very important feature. And so indexing on the field is, by although it's by default enabled for the object, but you can turn it off for and to make it little more faster, you can turn off the default indexing and turn on only the indexing on certain fields. Okay, so you can do that. All right, so the other features or other things you could do with a MongoDB is geographical search. Okay, geographical search as in restaurants within 5 kilometer radius from your point, or people in a polygon. Okay, people in a polygon. Okay, you must have seen these apps nowadays where you can find restaurants nearby you, or you could draw a shape on the graph and it will show you the restaurant inside that shape. Okay, so those kind of facilities are very well done using MongoDB. And using there are although there are few more systems like Solr who provide you this kind of functionalities. All right, also the functionality which were not there in kind of Microsoft SQL, I think they are now enabled in Microsoft SQL and MS SQL. And the text searching. Let's say you have humongous text in a particular box. Okay, in a particular field, you have huge text, and there are many records containing this kind of text, and you are looking for keyword search. You want to provide your users keyword search. Now, that's very much possible today with MongoDB. Using text search combined with restaurants and various indexes, you can do really, really complex querying on the database. Okay, and text search not only provide you the normal text searching, but also provides you these incredible facilities like stemming. Stemming means work and working is the same word. Work and working is the same word. Teach and teaching is the same word. So as per stemming, these kind of deviations of words are considered while searching. All right, good, good. Also, it provides you many language supports. Okay, so you can search using different kind of languages. That's a very good thing which MongoDB is providing you. So if you have a need of querying the data, let's say you want to churn the data based on reasons. You have already predefined reasons, and based on those predefined reasons, you want to churn data, you want to do some computation. In those cases, this querying on DB inside MongoDB would help you a lot. Okay? So you can utilize you can utilize MongoDB for doing the geospatial search basically. Okay, text searching or geospatial search. All right. Now this querying is very well facilitated by MongoDB using something called aggregations. They call it aggregations. Aggregations are chain of functions using which you can do the filtering of the data, querying and filtering of the data. Okay. So by the way of aggregations, you can query and analyze the data which is lying in the in 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 the MongoDB. All right. So now, other than the aggregations, there is one very good thing which is provided by MongoDB. It is MapReduce. Okay, so it is MapReduce. So although you can query most of the data using the usual find command and other query language provided by MongoDB, but there will be certain edge cases where you will not be able to utilize the MongoDB to uh, give you great results. So sometimes you have to programmatically find data. In those cases, M- MongoDB provides Mon- to you MapReduce as well. So you can have MapReduce on top of MongoDB so that you can do a lot of computation of various kinds. Okay. So the way it happens is, so map runs on all the nodes parallelly, which contains the data. So one member map will run on one member of the replica set based on based on where all the data is located for a collection. So we run MapReduce over a collection. Also, please note that while all of this MongoDB sounds cool, but MongoDB does not provide joining two collections. While in case of relational databases, joining two tables is very important aspect. It's like a basic feature. It's like assumed feature. And but MongoDB or HBase does not provide you a way to join tables. Okay, the only way to join the two tables is you concatenate the two collection, put it them in a single collection, and then query that using maybe MapReduce or using aggregations. Okay, so a MapReduce can run on a single collection, and then in the MapReduce, your map function will be executed near the data, and whatever is the result of the map function will be combined using reduce function. Okay, so this is how MapReduce works. So have you already talked about MapReduce? So in MongoDB as well, for certain kind of analytics, for certain kind of computation, when your usual querying is not sufficient, you can also do the churning of data using MapReduce. All right, all right. So these are the aggregations. This is how aggregation looks like. So you could chain things together, saying first pick up 10 columns from this collection, then you try to run a match, then after match run group, and then sorting. So MongoDB provides you this kind of a query language. MongoDB provides you this kind of a query language where things could be concatenated one after another, and you can build a full pipeline of operations which can clean the data, churn the data, or do your analytics for you. Okay. So other than MapReduce, this aggregation is quite powerful and flexible. All right. So you can see that here, this is how an aggregation pipeline looks like. Okay. So let's say you have this collection called orders. Orders is a collection, and it has got how many objects right now? One. How many documents? One, two, three, four. So we are saying db.orders.aggregate, and our first operation is match. Match means find out only those documents which are matching this condition, which is status colon A. So it will filter out only those documents whose status is A. So you got three documents. Next is you said group. Group based on customer ID. So now all those documents whose customer ID is A123 will come together, and A B212 will come together. And how to summarize the operation? By saying total equals to summation of this. So that's our aggregate operation part of the group, and there are the results. So we filtered the data by A, by status equals to A, and then grouped and summed up the data. All right. All right. Is the aggregation pipeline clear to you? It's more or less like your SQL. And yeah. All right. Great. Great. Anusha, is that clear to you? Do you have any questions for me on this? All right. Anusha is saying, can you explain this slide again? All right. So aggregations. So one way of computing do the computation on MongoDB is MapReduce, meaning you run map and reduce just the way we ran the MapReduce in Hadoop. The only difference is instead of input file, here it's collection. Second, the output data is going to be stored in MongoDB again, and all of this computation would happen on MongoDB. Now that was the MapReduce. Now the first preferred way to do the analytics or to churn the data on MongoDB is using aggregation. Aggregation is generally a bunch of operations in a certain sequence, and that is what is known as aggregation pipeline. So for example, here you could say db.usgs. So you can see here that db.usgs.aggregate has got one operation. Whatever is the result of this operation went to this operation. Whatever is the result of match went to the group. Whatever is the result of group went to sort. All right. You can see db.orders aggregate. Here is one condition. Here is another. All right. So this orders, this particular collection has got four document. This. The first operation called match gave us only three documents, right? Because status equals to A is the condition in the match operation. Okay, and therefore only this, and this, not this. Only these first three documents are copied into output. Next is group. When you say group, you specify that this is my ID column, meaning I'm trying to create group based on this, and my total is summation of this amount. So we grouped the elements by customer ID and then computed the total and saved it here. Sounds good to you? Now Anusha? So aggregation pipeline is a combination of a chain of aggregations where the output of one goes as input to another. All right. Sometimes you want to store really huge file just like HDFS. Okay. In those cases, you use GridFS. In those cases, you could use GridFS where you would like to store very large files, and it gives the ability to jump to a particular location in the that movie or file wherever you want to jump. It's great for video streaming services such as video streaming services, okay, such as YouTube. Here I wanted to say Vimeo, okay, or YouTube. All right. So this GridFS is great for storing very large files. It gives the ability to jump to a location inside a file, and it's great for storing videos and other things. All right. So GridFS is a facility provided by MongoDB, and what actually GridFS does is whatever file you give to GridFS, it breaks it down into smaller chunks and creates documents out of it. Okay, so basically GridFS is nothing but a facade, a kind of interface which internally utilizes MongoDB to do these kind of operations. So all GridFS does is it splits the incoming file into documents where each document is 256 kilobyte, and then stores that document into MongoDB as part of one collection. Okay, and that makes it possible to handle huge files. Okay, now when you break down a big file into smaller chunks, what happens is you can quickly jump to another place and you will land in another document. Okay, so you can independently talk to the document. Make sense to you? All right. So we have gone through the hands-on exercise. I would strongly recommend that you go through the this hands-on exercise, and a quick way to remember what is what in case of MongoDB. In case of RDBMS, what we call it is a table. Here it's called a collection. A row is a JSON object or JSON document. Index is equal to index. Joining is not there. So either you combine multiple objects into a single one, meaning embed, or you try to artificially create relations. And when we split the table in RDBMS into partitions, here it's called shard. All right, that's a there's a description, there's a comparison to RDBMS. All right, so there are many users of MongoDB. There are many use cases of MongoDB. It can be used for social and collaboration apps, data hub, storing big data, mobile apps, database as service, product and asset catalog, security and fraud applications, content management and delivery services. So lots of people actually use MongoDB to store the data from content management. Right? There are many industries which are using MongoDB, starting with news and media, online advertising and marketing, finance and e-commerce. Okay, and for customer data, for education, gaming, and government. So there are many use cases of MongoDB. Also have a look at the job. You should take a look at the job market by going to indeed.com. That's good way to find out. Okay. So you can find out more about MongoDB at these locations. And in case you want to dig deep into MongoDB, you can let us know. We can share with you our pre-recorded courses. All right. So that was about the MongoDB and HBase. So we talked about two kind of systems, HBase and MongoDB. HBase stores data into a very big table, okay, which has got many columns and many rows. Okay, so HBase is great for humongous data, humongous as in 100 million rows. Okay, below that it's not good. While in case of MongoDB, even if your data is few hundred gigabyte, that's a recipe for starting with. Okay, few gigabyte is also okay with MongoDB. Lots of websites store their data in MongoDB. Wherever you are using caching, you can use MongoDB. All right. Now, so those were the use cases, the comparison of use cases of HBase and MongoDB. All right. In case of HBase, it was not highly available because of the there was no such thing called election in case of HBase. We marked some node as HBase master, while we marked other nodes as region servers, and that's all. So there was no automatic election of various nodes. Okay, so that's the difference between HBase and MongoDB. Make sense to you now? Any questions at this point of time? All right. So to store structured data, you could use either HBase or MongoDB and then Chan. We talked about these two ideas called MapReduce and NoSQL, and they got used here. All right. Now let's start our discussion with Spark. All right. All right. So Hadoop was great. Hadoop was great, but it was great only for batch processing. Every Hadoop job, even you remember the one which we ran, Hadoop streaming, it was slow. It was slow because it was reading data from HDFS and then trying to write back to HDFS. So Hadoop was good for batch processing, and the moment you skip the disk and you try to do the computation in memory, it becomes suddenly 100 times faster. Okay, so while on one hand MapReduce, Hadoop's MapReduce was designed with the mindset that we have to get things done no matter how many nodes and no matter how much latency does it have. Okay, but in case of really fast-paced computing, you cannot afford to have batch processing, right? You cannot afford to have MapReduce kind of engine when you have really, really fast-paced computing, okay, such as real time, and that's where Spark comes into play. Spark is actually a faster version of MapReduce. We cannot call it faster MapReduce actually. It is a little bit different. We will go into those details. Okay, it's 100 times faster than Hadoop's MapReduce in memory. Okay, it's 10 times faster than on disk. Okay, it builds on similar paradigm as MapReduce. Okay, and it is tightly integrated with Hadoop. Okay, meaning it can store data anywhere. All right. So if you remember when we talked about Hadoop's MapReduce, we talked about that it reads data from HDFS, it writes data to the HDFS, right? And every time you have to do anything, you have to write map and reduce and go through the full routine. If let's say one map reduce phase has to be fed to another as input. Okay, the output of one map reduce phase has to be put to another map reduce. Now what will happen is it will become first very slow. Second, you'll have to first serialize and deserialize. If we are talking about complex data structure, you will have to first convert that data structure into a stream of text, and then again in the next map reduce we have to load the set and convert that into an object, right? So there's too much of serialization deserialization going on. Okay, and that Spark solved by keeping most of the data in memory. And how Spark was able to afford that much memory? Because just like just like MapReduce, Spark is also running parallelly on many nodes. Okay, therefore it could pull in their memory and utilize that memory to do the computation. And that's where this Spark comes into play. So it pulls in the memory of all the nodes, and that's where it loads a lot of data and can do the computation for you. All right. So prima facie, Spark is kind of replacing Hadoop's MapReduce, but Hadoop's MapReduce has got its own advantages. It's great for batch processing. In the Lambda architecture, when we talk about batch processing, Hadoop MapReduce does a good job. All right. Now let's try to understand this ecosystem. This is very important. In the ecosystem which we earlier discussed, we did not go into the ecosystem of our Spark. So Spark is a computation engine just like MapReduce. It provides you a way to do the computation on multitude of computers. If you have 200 computers in the network and you want to do something on them quickly, Spark is your go-to component. Okay, so the main and most important idea about Spark is the Spark core, and this core can run anywhere. Okay, so Spark can run on top of Hadoop cluster, right? It can run on top of Hadoop cluster. It can also run standalone, meaning you installed Spark on 200 computers and you booted them parallelly. Now they will talk to each other, and you can basically launch your Spark job, which can launch the work on all these nodes. So that's standalone. Similarly, you have Amazon EC2's installation, or it can run on Amazon EC2 as well, and it can run on another resource manager called Apache Mesos. On Mesos also it can run. And what is Mesos? Mesos is similar to Yarn, which makes sure that so Mesos is kind of a resource manager of a big network. So if you have many computers and you want to get something done on them, you can install Mesos layer, and on top of it you can install Spark. But we are not going to go through that route. We will concern ourselves with Yarn cluster because Spark does not provide storage. Spark does not provide you a way to store files or data. It only provides a way to execute your programs on the computers in your network. Therefore, it is wiser to have Spark on top of Yarn, because Spark makes sense only if you have a lot of nodes, okay, or you have a lot of cores in a current computer. Therefore, Spark combined with Yarn is a very important aspect. It's a very important combination. So if you combine Yarn has provided you the very good suite of components. Or if you think about Hadoop has provided you great suite of components starting with Yarn, HDFS, and there are many more components. Okay, so it makes very much sense to have Yarn and Spark together, and that is the beauty of it today. If you just install Ambari, okay, Ambari is a provisioning server. So if you want to set up your cluster with Yarn and all of these analytics, your thumb rule is first install Ambari, install Yarn, then install Spark. Okay, so all right, so I'll try to describe to you. Uh, okay, I think these kind of case studies are more important. Okay, let me try to describe to you the analytics which we are doing with Dell. I'll reiterate through this analytics again when we talk about it. So at the base, we have Hadoop. Okay, so Hadoop is like a playground. Hadoop, and there are many nodes. There are many computers inside it. Okay, we have like 6 7 computers for POC, and we have installed Hadoop on this. So we have installed Hadoop on this. Just like the way we have our Cloud Labs. When I say Hadoop, Hadoop means these are all part of the Hadoop cluster. This one has name node, this one has data node, this one has data node, this one has region server, this one has HBase master, and so on. Okay, so first we installed Hadoop. On top of this layer, we already installed Spark. We already installed Spark. Now the user data, now the user, and on top of, so sorry, um, here we also installed, ouch, we also installed something called Kafka. Kafka is a queue. So on one end, their Dell's team, okay, from Dell, the data is coming in. From the Dell, data is coming in. We are running our program on top of Spark. Okay, we are running our program on top of of Spark. The data is coming to the Spark. Okay, and here, so these are from Dell. We are getting orders in Kafka. So Kafka is a queue, meaning there is these data packets coming in. Okay, that's how you can imagine inside Kafka. There is these nice data packets are coming in. So this is order number one, order number two, order number three, order number four, and so on. And we are consuming the data from these orders. All of these orders we are consuming, and this we have written in something called stream processing. Okay, here is our logic. Okay, our program utilizing stream. Okay, utilizing Spark. Let me just write Spark for time being. Okay, so it's talking to Spark, loading whatever data is coming in. Okay, it's talking to Spark and loading whatever data is coming in. Okay, and then when the data is coming in from here, it's again after churning the data, it's again putting it into another queue. Okay, it's putting in another queue. Okay, from there somebody from there we are sending it to charts. Okay, sending it to charts. Here there are like many components, but I don't want to get into that right now. Okay, so generally when you have lot of data, you have this line, this side of data, this side of requirement as well, that whatever is the latest data coming from the production, push it to Kafka, so that so that if if Dell is slow, then our program so imagine this, if program is reading directly from Dell, what will happen is, if Dell is making it wait, then it will keep on waiting, and then suddenly Dell will give thousands of records in a millisecond, and then it will become busy. So to avoid such kind of irregularities, it's important to have a big pipe. Okay, it's important to have a big file. The same reason as uh, you have the water tank. In water tank, from one side the motor pushes the data, pushes the water. On the other side, it comes to your home. Now, since there is a difference of flow between the motor and you, therefore the tank exists. Motor can quickly fill the tank, while people consume the water slowly. Okay. So to fill that gap, we have tank, and similarly we have a Kafka queue here. So that if Dell has produced so many records, it will put it in the queue, and program will keep on consuming it at a continuous pace. Alright. So generally, this is one of the ways you churn data, and therefore it is again important to know at least the basics of Spark. Okay. So for storing, Hadoop is good, but for churning, you need systems like Spark. Okay. All right. So Spark Core runs on top of Yarn, runs top of standalone, and runs top of other things. And Spark can read the data from HDFS, data from HBase, and data from Hive, and data from another file system called Tachyon. So Tachyon makes sure that similar. So while reading from Tachyon, HDFS, HBase, or Hive, Spark knows that which are the node that are closer to the data. Okay. Now it utilizes that fact and executes logic only on the closest data. Okay. So Spark Core can read from a variety of file systems. It can read from variety of file systems, and if you are not quite comfortable with programming, you can use SQL, you can use Spark R on top of Spark Core. Okay, while so here in this diagram, although it shows that, so I'll just try to. All right, so let me just a second. All right. So, yeah, let me try to put it properly. All right. So we have Java, Python. These are the programming language with which we could do the computation. Okay. I think now the things will be far more clearer. All right. All right. So I think now the diagram is far more cleaner. Here, what I'm trying to show you is from this side we have libraries. These are libraries, meaning the facilities, and on the other side, okay, so you have libraries and you have programming languages, meaning a way of interaction. Okay, so the difference between the two is those algorithms which are fairly complex and very useful, they have been pushed to these libraries, be it MLlib, GraphX, and streaming, while on the left hand side, these are the languages, a way of interaction with any of the libraries or the Spark core. Okay, so these are the supported languages by Spark. So a user interacts with libraries through these languages. All right, so you can either talk to Spark using SQL, Spark R, Java, Python, or Scala, or a combination of these. All right, Spark also has grown to provide you these libraries which utilize Spark core, meaning get things done. These libraries get things done, get very useful things done on top of Spark. For example, GraphX library is a graph library. What does graph library do? It provides you facilities to do the graph operation. Imagine this. Imagine this. Your task as an analyst is find the rank of the people on Twitter. And it's not that easy. The definition of rank is a person being followed by many people gets the rank as summation of all the ranks. So all the people say I'm being followed by very important people, so I'm more important. And this importance comes from the people who are who are following me on Twitter. So if you have to do this kind of a complex task, that find the rank of the people based on how many people are following them and what is the quality of them, what is their rank. Okay, so this is called PageRank algorithm, the algorithm because of which Google exists. Okay, because of this algorithm, Google became Google because Google started giving ranks to various websites based on who is linking them. Okay, so if you have to do this now, it's very easy. You can, if you have like 10 computers, you can actually compute. If you have, say, maybe 5, 6 computers, 5, 6 nodes, you can actually compute the page rank of Twitter. All right, sounds good to you? So similarly, if you are writing some kind of algorithm, find common friends, or that kind of analytics you want to do, that how many common friends people have, or other kind of complex structure ones, you can utilize GraphX. Also, at the same time, if you have to do machine learning kind of work, whether it's statistics or complex one, meaning learning from the past data and do something magical, that's what is machine learning all about. It contains really beautiful functions. It contains a very rich functions to, so that you don't have to write those. Okay, also MLlib provides you far richer library with respect to constructs, so that you can do a lot of machine learning algorithm development. Stream processing is when you want to process really fast stream of data using these libraries. So basically these are the very rich libraries which Spark is providing. Okay, and you can use Spark using any of these languages. Sounds good to you? All right, all right. And you can read the data. Therefore, because of these reasons, probably you as an analyst would actually end up interacting with the Spark more than any other thing. Okay? Because that's what is happening with us also when we are working with Dell and when we are working with a couple of companies. The overall outcome is that we are actually busy with Spark. Hadoop is set up, HDFS is set up. All we have done with Hadoop is that we have stored our data. Now we are on focusing only on the Spark. Okay, our most of our time goes in interacting with the Spark. Also, it can read data from HDFS and saves the output back into any of these file systems. All right, so that's our Spark. If you want to install, it's not a big deal. You can just download and start it. All right. What I wanted to discuss is that how does Spark do what it does? Okay. What makes Spark Spark? All right. The core concept behind Spark is the main concept is resilience distribute dataset. Okay. So it takes your data, puts it on multiple computers, but it tells you that your data is still intact. So under the hood, this division of data is managed by Spark. All right. So let's continue our resilience distributed datasets discussion tomorrow onwards, and then we will go into Flume and Scoop, and we'll also try to do a couple of examples. All right. Have a great day. Hi Anusha. Hi Madhi. Have a great day. We'll see you tomorrow. Bye bye. Thank you very much.